Okay, so hello, welcome. I will talk about de-vendoring Gnulib in Debian. Gnulib, maybe not all of you are aware of it, but Gnulib is a source code reusable library published by the GNU project. It's to offer reusable components for various projects, mostly C, M4, some shell script, some ancient languages. It happens to be used by a lot of top popcorn packages that we may not realize that they're using Gnulib, like core utils, Bison, awk, gzip, sed, grep, find utils, wget, nano, and so on. And all of these are using different versions of Gnulib. Gnulib is usually used as a Git submodule within the upstream project, but it's not shipped directly in the release tarballs. It's shipped. It's produced through the Gnulib tool that copies some files, and that ends up with a tarball. So you get vendored, and by vendoring I mean that you use some third-party code into the release tarball, but you get vendored versions, different versions of Gnulib into all of these upstream projects, together with some newly pre-generated files like M4 stubs, makefile stubs, and so on. And everyone is aware of the XZ incident, and it must have lots of different consequences or backgrounds, but one of the problems was challenging or auditing the difference between the release tarball and what's upstream. And it happened to be one of the Gnulib files, which may or may not be a coincidence depending on coding style and so on. And this made me start to look at the Gnulib package in Debian. It's been in Debian for quite some time, but never used for building other packages. So instead, Debian packages, all of these packages use the upstream tarball with different versions of Gnulib, and creating these challenges to audit content. And we haven't had a security problem in the Gnulib code that I can remember, but there is no. If there is a security problem in this code, patching all these projects will require manual work for each and every one of those projects. That could be moved to a central Gnulib package. Yeah, and this is about some of the. There are also another problem is auditing files from upstream tarballs for legal reasons, like the Debian copyright file. And if you're not vendoring the files into Debian, you don't have to audit them for legal compliance as well. So my objective is a bit to simplify work and not have to do tedious, fragile work to audit the upstream tarballs, which you need to do on every release. In Debian, we usually have a practice of doing quite a good work when we initially package it in, and the FTP masters do a copyright review. But once it's in Debian and new releases, maybe the different quality on different maintainers, but I suspect that the quality isn't increasing, at least. Another challenge is that it's surprising how these tools work. I think a lot of people believe that running auto-reconf regenerates all files, and it's just a basic misunderstanding. It was not meant to do that. It's been successfully used in Debian to solve some of those problems, but mostly by coincidence. So going into how to solve some of these problems, the first basic approach is if you're maintainer of a C package, a C-based package that uses Gnulib, the naive or basic first attempt solution would be to just add a build depends on Gnulib, and in your Debian rule files invoke the /dot bootstrap script to rebootstrap all the vendored and pre-generated scripts. So some packages do this. Most packages rely on the DH auto-reconf to do some of what the /dot bootstrap script does. But any improvement would be to actually run it in Debian rules. I didn't know about it, but I noticed the inet utils package just started to do it this way quite recently. But there are three problems if you approach it this way. First is that your package will not use the same Gnulib version that upstream used to prepare the tarball, which means it might not build, because Gnulib is a source-only package. There are no release tarballs, it's no versions, it's just clone from Git and use the latest head. And that's what maintainers usually do when they prepare a new release, which means you get many different versions. But for Debian, the Gnulib packages only ship one version. That's not necessarily compatible with all upstream packages. So we need to solve that. Another problem is that not all files are necessarily regenerated, like the auto-reconf misunderstanding. And the third is that there is no way to fix security bugs. So let's start on the first one. An improvement to do this. This is basically the problem. The inet utils 2.5 tarball was prepared using a particular Gnulib git commit. Gnulib built this using the latest Gnulib in Debian, which is using a different git commit. So next time Gnulib is updated, it might not build anymore. It might not even do what the upstream maintainer wanted it to do, because the Gnulib doesn't promise any internal future or backwards compatibility. The maintainer picks one version and makes sure it works for that version. So the problem or the solution here that I picked for the Gnulib problem was okay, let's just ship a Git bundle of the entire upstream Gnulib project. I don't know if anyone realized I did it, and maybe someone will object to this practice, but it seems compatible with the way Gnulib is intended to be used, that you are allowed or recommended to pick some Gnulib commit, pin to that commit, and use that version. So instead, if you're building a package, then run /bootstrap pointing an environment variable to this Gnulib git bundle, and it will normally use a networked git clone to check out the Gnulib git repository, but with this local way, it will use just a local clone instead. And the Gnulib revision environment variable will instruct the bootstrap script to pick out a particular commit. So this basically solves the problem that you're using different Gnulib versions. of course, it creates some new problems. I'll come back to that later. So another problem is that not all files are regenerated. So let's see how to solve it. And that was the XZ incident, that some files contain malicious code. And if you were to, or had regenerated those files, it wouldn't have been used. And I think fundamentally the problem is that these pre-generated files are there in the first place. They are useful in some situations, like a user running a Solaris machine and wants to download some piece of package and get it to work. Then it makes sense to have some helper functionality or some pre-generated scripts or some vendored file. But for building a Debian package, it's mostly causing problems. So my idea to improve this is to filter the release tarball from all vendored and pre-generated files before we use it in Debian. And if you're able to build your software from this minimal tarball, you have solved this problem. During trying to get this to build, you'll probably realize that you're missing some dependencies, but they were probably bugs in your earlier packaging that you needed that dependency to rebuild some files that you didn't used to rebuild. So I think this is a pattern that promotes a more maintainable approach to make sure that you're regenerating or actually using files from source code that's used in the build process. And I think this is something upstreams can consider, to instead of releasing tarballs with a lot of vendored and pre-generated files, they can instead publish a Git archive-based copy. I know this is an interesting topic on its own, and there are lots of different opinions on this, so I'm trying to stay out of that, just giving that it's possible to solve the filtered tarball issue in several different ways. Either use the official tarballs and filter them, get Git archive from upstream, or create a Git archive tarball yourself. And finally, I think there is some resistance on this because it adds work. So I fully admit that maybe we shouldn't just care about this problem because it's too much work. Some Debian maintainers may think that this is not worth solving. I mostly disagree. I mean, the XZ incident showed that this is a real problem, and unless we do something, I don't think it will go away. But there are maybe better solutions to this. So stripping down the tarball that we are using solves the problem of regenerating all generated files. So we still have the issue of, so let's consider if there's a security bug in some Gnulib code, how do we patch that without patching all the core utils, sed, and etc. packages directly? And this took some while until I realized one way to do it. And the idea is quite simple, that after cloning the Gnulib Git directory and before using those files, run some command that performs a patch, patches this code. And that's what basically this dh Gnulib patch command does. It's a very short shell script that iterates through .d style directory that contains several patches and make sure that at least one patch in each directory gets applied successfully. And the reason for this complexity is that this patching has to work for all Gnulib Git commits, which is a bit more interesting. So the Gnulib code is evolving, but if you're patching a security problem, the security problem may occur in like 10 different versions of the same file, but you still need to patch each or maybe 5 of those versions because 5 versions were used to build one of the important packages. I think once implemented, this is fairly easy to approach, but it may look a bit complex. People dislike doing Debian patch editing and maintenance as it is, and this makes it a bit more complex. And there is some auto-package self-tests to actually make sure that Gnulib patch works for all commits. So otherwise it would be quite fragile. So going into some details, this is for the Debian package maintainers here. But the idea is first to disable the auto-reconf DH sequence because it's not needed and actually more incompatible with this approach. And the last line tells the process to first clone a Gnulib directory, invoke the per project scripting to pull this Gnulib into the build directory, and this is something that may vary between each upstream, but all of those projects I mentioned in the beginning are using Gnulib's bootstrap script, which supports this --pull parameter. So it's fairly well supported, but you may need to adjust it. And the next part of the sequence is running the patching the Gnulib directory before it's used, and the final part is running the --gen step of the bootstrap script, which basically runs the auto-reconf tooling with some more complexity on it, but it's essentially the same thing. And internally, the clone command and the patch command are just very simple invocations of git clone and Gnulib patch. So it's fairly simple. It even fits a slideshow presentation, this implementation. And I did it for a quite obsolete library, but it was a good example to try this pattern on libntlm. So it builds on, or build depends on Gnulib and uses this pattern. So it solves the 3 problems I could identify with a naive approach. So now at least this package is ready for other attacks. And a nice thing with this is that the upstream tarball is identical to a Git archive style archive, which is minimal. It doesn't contain any vendored files, no pre-generated files, and we're still able to build it for Debian. I think that's a nice property, and if the XZ archives would have been looking like that, it would be much easier to have spotted any attempts like that. So wrapping up some open issues, I think this filtering of upstream tarball is only needed to reduce the size and attack surface of those tarballs. I think some people disagree. I think that's maybe we can find other patterns to work on that, or maybe ask upstreams to adopt this Git archive approach instead. Another interesting thing is that this adds a build dependency on Git, and Git is a complex package with a lot of build dependencies on its own, and if there is someone working on cross-platform or porting to new architecture, I would love to chat with you if this is a real problem or more of a theoretical problem. And it's possible to use solve this with maybe a question.
I think I can directly answer this. The Git package is multi-arch foreign, so it is completely irrelevant to cross-building, and all the cross-bootstrapping will be entirely unaffected by the added Git dependency. There also is native bootstrapping, and that's something Daniel Leidert is working on, that may be affected.
Okay, thank you. So at least that reduces it to native bootstrapping of new targets. But still, it's an interesting theoretical concern that we're adding new build tools that may have cyclical dependencies. And also another open issue is how to generalize this. The bootstrap pattern is not specific to Gnulib. A lot of packages that doesn't use Gnulib uses the bootstrap script to set it up for building. I think the GNOME package use like autogen.sh. And I've been chatting to some Rust people here, and this final pattern of using a Git bundle may be one approach to consider for packaging some Go or Rust package that are used in multiple versions in the Debian archive. So I think that's time's up. Thank you. Any questions? Yeah.
Thanks a lot, Simon. We're a bit out of time, but we can take one question, and I guess we move to the rest to the break.
Thanks for the talk. I noticed that your announcement had a different title than your actual talk, because the announcement was devendering Gnulib and your talk was devendering Gnulib in Debian. So, my feeling is that this whole approach of bundling a random commit of Gnulib is super problematic. It also breaks all kinds of other things, like for example, you cannot bisect a bug fix or something like that. So I'm wondering, why does Gnulib work like that at all, and shouldn't that be changed on a fundamental level? It's called Gnulib, but it's not really a library, and I think it's extremely problematic. You mentioned XZ. I have a lot of thoughts about that too, but yeah.
Yeah, I think that's a deeper question, and I think most of the things are trying to move from Gnulib code into shared libraries, like the libunistring, for example. But there are some things that are very small, and the C language, historically, people don't like to create shared libraries for 10 lines of codes. That's different in other communities like Go. But I think that's the main reason that people, okay, it's simpler to copy this code into your project than to create a shared library for it. So that's the history, but going forward, I think there's also another solution or purpose of Gnulib is portability, and asking for a shared library to implement some features cross-platform may be challenging too. For example, most of Gnulib is not necessary at all on a glibc platform. It's mostly for other platforms. So it's a good. I wish more were part of some shared library, but maybe we could do a shared library out of more functionality of Gnulib. I'm part of the Gnulib upstream team, so it's possible to discuss further too. I guess we're running out of time.
Yeah, we need to wrap this up here. I guess you can just use the break and chat outside. We'll be back in 5 minutes with Carsten on running large-scale Debian installations. See you soon.